Hello, today I want to share with you how to configure HSRP Hot Standby Router Protocol. HSRP is a Cisco proprietary redundancy protocol that provides gateway high availability. If the active router fails, the standby router takes over without interrupting the network. Cisco provides HSRP and HSRP for IPv6 as a way to avoid losing outside network access if your default router fails. HSRP is a Cisco proprietary FHRP that is designed to allow for transparent failover of a first-hop IP device. HSRP ensures high network availability by providing first-hop routing redundancy for IP hosts on networks configured with an IP default gateway address. HSRP is used in a group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. HSRP priority and preemption. The role of the active and standby routers is determined during the HSRP election process. By default, the router with the numerically highest IPv4 address is elected as the active router. However, it is always better to control how your network will operate under normal conditions rather than leaving it to chance. HSRP priority can be used to determine the active router. The router with the highest HSRP priority will become the active router. By default, the HSRP priority is 100. If the priorities are equal, the router with the numerically highest IPv4 address is elected as the active router. To configure a router to be the active router, use the standby priority interface command. The range of the HSRP priority is 0 to 255. When a router is configured with HSRP, its interface goes through 6 states. 1 initial. This state is entered through a configuration change or when an interface first becomes available. To learn, the router has not determined the virtual IP address and has not yet seen a hello message from the active router. In this state, the router waits to hear from the active router. 3. Listen. The router knows the virtual IP address, but the router is neither the active router nor the standby router. It listens for hello messages from those routers. For speak, the router sends periodic hello messages and actively participates in the election of the active and/or standby router. 5. Standby. The router is a candidate to become the next active router and sends periodic hello messages. 6. Active. The router is forwarding packets using the virtual IP and MAC, sends hello messages to inform others it is active. The active and standby HSRP routers send hello packets to the HSRP group multicast address every 3 seconds. By default, the standby router will become active if it does not receive a hello message from the active router after 10 seconds. You can lower these timer settings to speed up the failover or preemption. However, to avoid increased CPU usage and unnecessary standby state changes, do not set the hello timer below 1 second or the hold timer below 4 seconds. HSRP uses timers to detect failure. Hello timer, default 3 seconds. Hold timer, default 10 seconds. Active timer, time before declaring active router down. This means the standby router will take over in about 10 seconds by default. We can also tune these timers for faster failover. Okay, now I am designing the topology HRSP for configure together. Let's configure HSRP on 2 routers. On router R1 active. Here, 192.168.1.1 is the virtual IP address that clients will use as their gateway. HSRP creates virtual IP addresses that the hosts use as their default gateway. In this design, we have 2 virtual IPs. Virtual IP1 equals 192.168.1.1 for the inside LAN. Virtual IP2 equals 203.1.1.254 for the WAN side. This design provides high availability at both Layer 2 and Layer 3. EtherChannel protects against link failure between switches, and HSRP protects against router failure. Together, they ensure that the LAN can always reach the WAN and the server, even if one router or one uplink fails. At the bottom of the topology, we have PCs connected through to switches. To increase redundancy and bandwidth, EtherChannel is configured. The left switch uses PAgP, while the right switch uses LAcP, both connecting up to the distribution switch. This ensures link aggregation and redundancy at layer 2.